Hey everyone, welcome back to the Foundations and Pre-Calculus 10 videos. In this video, we're going to look at Lesson 2 from Chapter 3, which is looking at perfect squares, perfect cubes, and their roots. Specifically in this lesson, we're going to look at what a perfect cube is and what we can do to determine their roots without using a calculator. So a perfect cube is the cube of a whole number. So for example, 125 is a perfect cube because 125 is equal to 5 cubed, which we can even rewrite as 5 times 5 times 5. So the side length of a cube, say if we're looking at the object, is the cube root of its volume. So what we do is we would go cube root of 125. If we were to punch this into a calculator, we would see that we would get 5 as an answer. So as long as we have a perfect cube, we can find its side length, and its side length will have a very nice whole number, no decimals involved. So we're going to take a look at example number 2 from your notes, where we're actually going to apply some of this knowledge to some problems involving rectangular prisms and volume. So a rectangular prism has dimensions 16 centimeters by 8 centimeters by 4 centimeters. So we want to know what is the edge length of a cube with the same volume. So just some important things here. Here we have the dimensions of a rectangular prism, and then what we need is the edge length of a cube that has the exact same volume. So this here's going to be actually a two-step question. So our first part here is we actually need to know what this volume is in order to even figure out what kind of side length of a cube would give us the same volume. So here we're going to find the volume of the rectangular prism. So if you guys remember back to your previous math classes, the volume of a rectangular prism is your length times your width times your height. And that is given by these dimensions here. So you go 16 times 8 times 4. If you put that into your calculator, or if you guys can do that by hand, which would be amazing, you guys would find that your volume is 512 centimeters cubed. So now we know the volume that we need to aim for. We need to find a cube, or the edge length of a cube that will give us this same volume. So when we're looking at, say, just the volume of a cube, because it has the same edge lengths, when we go to length times your width times your height, these here are all the same, so we can really just say it's your length cubed. So here if we know that we have 512 as our volume is equal to L cubed, if we were to get our length side by itself, we'd want to cube root each side. So essentially we're looking here for the cube root of 512, and that would give us our edge length of that cube. Now for this part here, we are not going to cheat. We are not going to use our calculators. I'm going to show you how to do this by hand, and this is exactly how I'm going to be looking for you to solve in your assignments. So in order to find the cube root of 512, what we're going to do is we're going to rewrite 512 using our prime factorization that we learned in our previous lesson in 3.1. So to do your prime factorization, what we're going to do is we're going to keep breaking 512 down into each of its factors. So first you want to look for two numbers that multiply to give you 512. And you can start with small numbers or you can start with bigger numbers. It really doesn't matter. Ultimately, as long as you do the math right, you'll get to the exact same answer. We also know, though, that if we choose bigger numbers, it'll end up being a little bit less work, or it'll be a smaller tree. So it'll help us save some work if we can try some bigger numbers. And so, for example, I can help you over here. If you guys tried dividing 512 by 16, you would see that it would give you 32. So 16 times 32 would give you 512. Then we're going to break down these factors as well. So I can break down 16 into 4 times 4. And I can even break down 32 into 4 times 8. I'm going to keep breaking down these numbers until I get to those prime numbers. So 4 can break down into 2 times 2, 2 times 2, 2 times 2, and 8 can be broken down into 2 times 4. 2 is a prime number, so you can keep carrying this down. And then we can break down 4 into 2 times 2. And what I like to do is, I know that some people don't like to keep copying and pasting all these numbers, but this kind of helps me keep track of all my numbers that I have so far in my prime factorization. So now my next step is I'm going to be cube rooting 512. So what I want to do is I want to group all of my numbers here into groups of 3. So here I have 2 times 2 times 2, 2 times 2 times 2, and 2 times 2 times 2. Now the big reason why I did this is because I can now rewrite 2 times 2 times 2 as 2 cubed times 2 times 2 times 2, which is once again 2 cubed, times 2 times 2 times 2, which is once again 2 cubed. So when I cube root something, that means I get rid of those exponents. So essentially what I'm left with here is 2 times 2 times 2 would be my edge length, which is actually equal to 8. So here my edge length, my L, is 8 centimeters. And then because this one here, I guess we can say that this kind of gave us into a bit of a word problem. We can write a sentence there and say, therefore, the edge length of the cube is 8 centimeters. All right, so that might be a lot there to process. And one thing that you could do to make sure you have the work right is you can put 8 cubed into your calculator. So 8 to the power of 3 into your calculator, and you should get 512. So just as a quick recap, there was quite a bit of information there. So assuming that we have a nice perfect number or a perfect cube like 512, we can find out what that number is when we cube root it by writing the prime factorization. Then we want to write our numbers, or these prime numbers, with exponents of 3. That way, when we cube root it, our cube root cancels out this cube. So we're really just left with these base numbers, which is 2 times 2 times 2, which would give you your answer here is 8. So ultimately here, the cube root of 512 would give you 8 if you were to punch it into your calculator, which is our answer right there. So that is everything here for this video. So if you guys have any questions, make sure to come see me in or outside of class, or you guys can also text me on Remind 101. And thank you guys so much for watching.